Okay, so Kelsey, if there's a problem with the transmission, please text me, okay?
Yeah, I'm all good. I think I
No,
had
I
a
just
second.
want you to monitor whether anything's going wrong, okay? So just text me if there's suddenly a problem, all right?
Got it.
Thank you. So welcome, everyone. This is a super special day. I comb my hair twice for this occasion. So this is Jeannie's PhD defense, and I first met Jeannie in 2017 when we went to Flint schools for a science outreach program. And at the time, she was a PhD in construction. And for some reason, she decided to switch fields, and we stole her way to environmental. And she's going to present a small part of her PhD journey to you here today. And of course, other parts aren't appropriate, including her work in Denmark, South Carolina, which revealed the water crisis there. And there's a CNN documentary called Dirty Water on that, plus a $100 million lawsuit, which we won't talk about today. So without further ado, we'll have her talk about a portion of her PhD work.
Thank you, Mark. He did a great introduction. And so I will be presenting on my dissertation titled Practical Application of NSF ANSI 53 Lead Certified Filters, Investigating Lead Removal, Clogging, and Consumer Experience. And so household filters, there's about 40 to 45 people, 45% of people in the US voluntarily use filters, whether it is whole house filters, pitchers, under the sink, just because they want to. But they are certified to remove contaminants under NSF ANSI 42 for aesthetic effects. You will find iron and manganese under those, as well as chlorine. As well, NSF ANSI 53 is certified for health effects. And so lead certification is under NSF ANSI 53. And so for lead remediation, these POUs are used.
You went mute.
Jeannie, you've just muted yourself by accident.
Okay. Y'all got me?
Yeah, we can hear you now.
All right, great. So our NSF ANSI 53 filters, they are for lead removal. They are tested with 2 challenge waters with 150 micrograms per liter of lead, a soluble and particulate condition. And these filters must remove, well, let's see. All right, so we are having more technical difficulties. Okay. These filters are required to reduce filtered water below 10 micrograms per liter, which was recently reduced to 5 micrograms per liter in 2019. Hundreds of thousands of them have been distributed to cities with elevated lead levels over the past several years. And so when talking about water lead levels in this presentation, I will be referring to these 4. And so 15 micrograms per liter is the EPA action limit. Violations of this level of lead cause for the requirement of municipalities to distribute POUs. 10 micrograms per liter is the certification level filter limit for these filters. 5 micrograms per liter is the bottled water standard. And 1 micrograms per liter is the goal by the American Academy of Pediatrics, because there is no safe level of lead concentration. And so these POUs were distributed in Flint, Washington, DC, Newark, New Jersey, and there were concerns about their effectiveness when they were distributed. And that is because the lead levels that were reported in Flint in this home had 184 ppb, and they were concerned the filters wouldn't work because that's above their 150 micrograms per liter. And some homes had up to 4,000 ppb, which is micrograms per liter of lead in their water. However, these POUs were proven to be successful in Flint. NSF did a study of over 240 homes where their highest treated water concentration was essentially 2.6 micrograms per liter and below, which is really good. And our team did a one sample evaluation where the POU removed 95.85% of lead. It did have an effluent level of 20 micrograms per liter. However, the influent was 13,200 micrograms per liter, which is pretty equivalent to toxic waste. And that was the worst sample that they had coming out of Flint. For this grant, it started in 2018 is when my filter work began, and it's funded under the HUD Healthy Homes Technical Studies Grant. And so the goal was to investigate the limitations of these POUs. It was to push these filters past their breaking point with the anticipation that the widespread application of these filters would not be sufficient for everyone. And so our testing was to test these filters under extreme conditions with high levels of iron and lead. We wanted to see their effectiveness when operated past their capacity up to 200% because people don't often change their filters on time. And to determine what the filter failure modes were when they are pushed purposely past their breaking point. And so that was anticipatory because in 2019, after we had begun this work, Newark, New Jersey had a problem with unreliable filters. And so they had the EPA required them to switch from their 40,000 filters that they distributed to bottled water because they had two filters that had elevated lead levels when they did preliminary study. However, this was a premature declaration because when they did a citywide test of 198 homes, only 5 of them had elevated lead levels. So most of the filters worked in that city, but they had already told the residents to not trust the filters. So there are ramifications when setting expectations for filter use. And so all of these strategies for lead remediation have limitations, and my whole dissertation is the goal is to seek to identify them. And so my first manuscript is understanding filter failure modes. And so this investigation looked to see when these POUs occasionally exceeded 10 micrograms per liter. My second manuscript was to look at the impact of iron on POU performance. Excuse me. And we wanted to evaluate the limitations that iron put on these POUs, especially when lead co-occurs in drinking water, as well as how clogging can impact the cost of POUs in comparison to bottled water. The third manuscript is a longitudinal field study in Louisiana homes. And we wanted to look at the long-term performance of these filters as respect to lead removal, clogging, and their practical use, as well as demonstrate the benefits and limitations of flushing when compared to using a POU filter. And so manuscript 1 is titled Understanding Failure Modes of NSF ANSI 53 Lead Certified Point of Use Pitcher and Faucet Filters. It's a long title, but it has been published in ESNT Letters if you want to go and check that out. And like I said before, the objective is to understand when they potentially exceed 10 micrograms per liter. And so the first phase is a laboratory study where we tested the 2 NSF ANSI 53 water conditions. We wanted to validate their performance in our lab to make sure that our protocol was in line with theirs before we made water that was purposely more challenging. And so the first one, we did the soluble condition and tested 10 POUs. And then the second one was particulate lead water and 7 POUs. We did them in duplicate up to 200% of their capacity with 16 samples for each POU. And we measured their flow rate and effluent concentrations. The next phase of this study was an examination of filter underperformance in the field, where we made 3 challenge waters of particulate lead in order to try to replicate that poor performance seen by a community. So we had some brand A filters at our lab, and they had 2 brand A filters in their lab, and they had really bad effluent lead levels that we had never seen before. And so they shipped us their filters along with some water, and we wanted to see why those filters behave differently. These are all of the certified filters that are on the market. You might see them at your local grocery store or big box store. There are a total of 11 filters, 4 pitcher filters and 7 faucet filters. And we do not disclose the names of these filters. So here on out, you will hear the filters coded as A through K. And so for pitcher filters, this is a picture of my pitcher filter setup. This was manually done by awesome undergrads where they had to fill the pitchers, time them with their stopwatches and dump them. In between each gallon, there was a 30-minute rest period, and we filtered as many gallons as we could in an 8-hour workday. For faucet filters, this was an automated system rig that I built. It had a 40-minute on, 40-minute off cycle, and 40 minutes is a lot longer than anybody would actually use their filters. And was really proud of this rig. As you can see, the middle picture is what it looks like overall. The picture on the left is the plumbing that's hidden inside, and a 200-gallon tank that we needed in order to make our water and filter it each day. And so here is our first round of results. This is 9 out of 10 of the POUs tested for soluble lead, and the filters worked in removing them. The highest sample of those was less than 3 micrograms per liter when we had influent lead of 150 micrograms per liter. And forgot to let you know, the x-axis is percent capacity and the y-axis is your lead concentration, and that will be consistent over the course of these next few slides. The filters worked in particulate lead, but only 3 of them out of the 7 worked well when filtering particulate lead. And so for these filter brands, they all produce lead below 5 micrograms per liter, up to 200% of their capacity. And I will be talking about the failure modes that we experienced with the other filters. And so we have modes of failure. We categorize them in 2 different ways: manufacturing, QA/QC, as well as performance. And performance is when lead levels exceed 10 micrograms per liter. And so one of the first manufacturing failures we had was that there were 2 brands of filters, and both of their duplicates, when installed running clean water, the units leaked in multiple locations. So before we could even test the soluble water, we had to replace those units. The second mode of failure is the first batch. And so this is a best practice. A lot of faucet filters and some pitcher filter manuals ask you to dump the first batch of water because there is residuals that come out. And as you can see here, although the effluent lead level was around 15 micrograms per liter, it did remove a lot. It still is higher than you'd like it to be. If you dump the first batch of water, you won't have to deal with that. And so if that sample was missing, this filter would be considered effective at removing particulate lead. The last manufacturing mode of failure is the duplicates. And so this one was pretty interesting. These filters came in the same box with the same lot number. And so these are pitcher filters. And so the duplicate 1 removed all the soluble lead. However, it clogged at 88% of its capacity, so it didn't make it. While the other filter, it started off a whole lot faster than any time we tested it in our lab. And then it continued to get faster. And so when it first started, it only removed about 50% of the influent lead. And then by the time we got to 150% capacity, it was equivalent to the influent lead. And in order to figure this out, we dissected the filters and we saw a hole inside of that filter. And unfortunately, this isn't the first occurrence, and some of the consumer comments for these filters in their reviews, residents talk about that the filters went really fast for some of them, and they did not make the water taste better. So they said they weren't going to use that brand anymore. So this manufacturing failure. And the performance failure, we attribute that to particle size of lead and that being challenging for the filters. And so guys gonna bear with me, we're gonna get a little technical. And so granular media filtration theory states that particle size may impact the removal of lead. And so on the x-axis, you have the size of the particulates. On the y-axis, you have removal percent. And so when you have less than 0.1 microns, you have soluble lead, and it is a really high removal because it's not particulate and it will be taken care of by the filters. In the next range, you have 5 microns and above. Those are highly removed because they're big particles. They can be removed by gravity or just the fact that they don't get through the media. And then your removal begins to go down when looking at fine particles. So you have, in this range is what NSF focuses on for fine particulates. It's between 0.1 micron and 1.2 microns. And then you have your last range, which has the least percent removal, and that is between 1.2 to 5 micron when we're doing syringe filtering. But when looking at the theory, it is between 1 and 2 microns is the lowest point when it comes to removal for filters. And so when comparing our water to NSF's, we had total lead, they had 150, ours ranged between 150, 170. They required total particulate to be about 30%. We range between 25 and 30. And fine particulate, they wanted it to be greater than 20%. And ours was between 0 and 20%. So a bit less than theirs for the fine particulates. And then for the bigger particulates, they wanted it to be less than 80% in their water. And we had an average about 94% of those bigger particulates in our water. And so we believe that even with our particles being bigger, that they're in the range that are harder to remove. And the way that we did this was making our water slightly different. And so our insoluble lead preparation, this is the steps on how we did it. So we have our big tank of water that has soluble lead. We take out a portion, and then we oversaturate with a higher lead concentration. And then we agitate it for 60 seconds by either stirring it or we shake it in a container. And then we add it back to the tank and allow for it to mix for a while in order for the particles to change their size. And so when looking at the particle formation method, NSF stirs their particulates where we shake them in our methodology. And so when looking at their fine particulates, they had 70% of their particles in that range, where by shaking them, you decrease that to around 40%. And in the range that is more likely to be least likely to be removed at 1.2 to 5 microns, you increase that percentage, as well as in the bigger particles, you increase that percentage. And so if you want to manipulate the size distribution of your particulate lead, then you would like to have them shaken and not stirred. And the reason why I went through all of that theory is because of these results. So we talked about the fact that 4 out of the 7 filters did not perform well for particulate lead. We talked about the first one, which was the first batch. failure. And now these are 3 different faucet filter brands. Technically, for certification, all of these points should be below that NSF 53 10 microgram per liter line. And that is not what we're seeing. And so the effluent lead levels, a lot of them for the different brands increase before even reaching filter capacity above that, and even above the 15 micrograms per liter for NSF, not NSF, EPA certification. And so for the brand K filter duplicate, it even got as high as 32 micrograms per liter of lead before reaching capacity. Even though that's about 75% reduction, it is concerning result when it's supposed to be below 10. And so for my second manuscript, we have iron clogging of lead certified point of use pitcher filters. And this is real samples of water that you have in some rural communities that have well water or are just on water systems that don't have the resources. And so discolored water, lead does not have color. And discolored water is typically due to iron and manganese concentrations. And so when faced with this, are they still low cost, reliable options? Because we've received anecdotal reports from consumers that they won't use the filters because of clogging. And the objective of this study was to look at the limitations of POU performance when tested with iron, and to consider how clogging impacts the cost relative to bottled water. And so our phase 1 was laboratory testing of these POUs, which the technique is similar to the first paper, but we only tested 3 pitcher filter brands and 3 particulate iron water conditions. And then we had 2 iron and lead combination water conditions. One of them was soluble combination and one of them was particulate combination. And the phase 2 was a cost benefit analysis to examine the effects on reduced capacity in comparison to bottled water. And so the POU removal of iron, you have how the concentration of iron makes the water discolored. The circles show you which waters we did test in our lab. And if you look at the average iron removal, you have removal between 96 to 99%. So the filters performed really well. And the SMCL is the secondary maximum contaminant level by the EPA, and that is 300 micrograms per liter. The effluent range for all of them except for the 20 microgram per liter iron were below that 300. And so the filters were really effective in this. When removing both iron and lead, these are lead concentrations. And so for our soluble lead concentrations, you have the capacity on the x-axis and then the lead concentration on your y-axis. For our soluble combination water, we use 0.3 milligrams per liter and 200 micrograms per liter of soluble lead and iron. And we have this first peak by a brand A filter, and that is about 45 micrograms per liter of lead, but that did not correlate with a release of iron. And then a little bit later, we have a peak that is close to 15 micrograms per liter of lead. However, that also did not correlate with a release of iron. For the particulate iron combination water, we use the same amount of lead and iron, just in their particulate form. And you had brand A made it all the way to their 100% capacity with only, and all of their effluent lead levels were below 5. But brand B had effluent lead levels above 10 on that first batch. But like we said before, if you dump that, the lead level will go down. However, it clogged around 30% of its capacity due to the iron in the water. And so here's how we define premature clogging to kind of get this idea in your head. NSF 53 defines clogging as a 75% reduction of initial flow rate. And so if you have clean water for a pitcher filter, it may take 25 minutes to filter a gallon of water. That means that we will wait 100 minutes before we declared failure in our lab. That is hour and 40 minutes, guys. And then iron particulate water, which is the 0.3 milligrams per liter. And these are real representative results. Your initial gallon can be a lot slower. And so it can be that hour and 40 minutes to filter your first gallon. But in our lab, we could not declare failure until 4 times that. And so 400 minutes. And that is roughly around 6.6 hours to wait to filter 1 gallon of water. And we consider that to be unreasonably slow before capacity. And that's what we consider to be premature clogging. And so I mentioned this so that you can see what reduction of flow rate looks like. And we have first our brand A filter. In the legend, you see that it has a capacity of 15 gallons. And so although that is our blue triangles at the bottom, although it did not have a reduction in their flow rate, it treated the least amount of water because it had the least capacity. And then when looking at brand B, it had 120 gallon capacity. It did not make it to 50% of its capacity, but it did treat more water than any of the other ones. And then brand C had a 40 gallon capacity and it treated about 25 gallons of water before reaching that failure point. And so when seeing the impact on cost of these POUs, this is what I wanted to illustrate for you. Store brand bottled water, POUs are ideally cheaper than buying bottled water. And that is true if there is no iron in your water. A POU, well, this brand B POU pitcher filter is 5 times cheaper than store brand bottled water when you have no iron in it. However, when you increase that iron concentration, it can quickly exceed and be up to 8 times higher than the cost of bottled water. And when compared to our brand A filter that only had that 15 gallon capacity, it was always more expensive than your store brand bottled water. And so when looking at filters, checking the price, the percent capacity, as well as the volume filtered is something to look at when considering affordability. And so that third manuscript is titled Long-Term Performance of Faucet Mount Point of Use Water Filters in Louisiana Households. And this is a longitudinal field study. And the reason we're looking at this is because studies have proved that POUs are effective in both lab studies and field sampling. With their occasional failures, they still perform very, very well overall. And we've even had lab studies that have tested these filters throughout their capacity and beyond, like my first paper. And then, but the large scale field studies that were done in Newark and in Flint, they take a snapshot of the POU performance, but they can't monitor throughout its lifetime with that many homes that they are looking for effectiveness. And so this study examines the long-term performance of these POUs in 2 communities in Louisiana, and we're testing faucet filters. And so manuscript 3, we're monitoring the long-term performance of POUs in Louisiana homes, but we're looking at lead removal, clogging, and practical use. We also are seeking to demonstrate the benefits and limitations of flushing when in comparison to using a POU filter. The first phase is the unoccupied home study, which tests in 2 different homes over the course of 20 days. We install rigs in these homes. The first home is the home with sustained lead, that before we installed this rig into this home, it had consistent lead levels that were above 15 micrograms per liter, no matter what day. And then the home with the disturbed lead service line, we were able to get a hold of a partial replacement lead service line from Louisiana, and we installed a 6 feet lead service line in front of our rig in order to illustrate the worst possible conditions to see how far these filters and how effective they are. We tested these duplicate filters up to 200% of their capacity, and the way we did that was filtering 10 gallons per day over the course of those 20 days. And we cycled 3 conditions over 7.5 hours for the 24 hours in the day. Our second phase is the residential sampling, where we just wanted to monitor the filters throughout their practical life as defined by the residents in New Orleans and Enterprise, Louisiana. And practical life looks like 12 weeks based off of the design capacity, or when the resident's filter turns from yellow to red, they will call us and let us know that their filter has reached its filter life, or when the residents said that the effluent lead levels were just too slow and they decided when those filters clogged. And when they did, they just called us, we asked them to take one more sample, and we concluded their section of the study. And so, I'm sorry. This is something I'm really proud of. This is a portable rig that we built, and I say we, I have 5 wonderful undergrads who went to Louisiana with me to take these rigs out of a box and put them together to run these field studies. And so in this first top left-hand corner, you see that these rigs have, they're essentially controlled by timers. So each condition had tap water being flushed through them at particular times, as well as to allow for that 7.5 hour gaps to occur. And the big picture in the middle, you'll see that we had the duplicate filters. You don't get to see what the filter is because we have blinded them, so you get to see my illustration. And then the third condition is the influent lead concentration that we used to measure the filter effectiveness. And this filter was battery powered so that we could not use the home power. And in the in the low left-hand corner, you'll see the battery, and it also has a sensor that would cut off the flow of water if there were leaks in the system. And so flushing to reduce lead levels, essentially, it is a common public health recommendation to reduce water lead levels. And they asked residents to flush their tap for 30 seconds to 2 minutes. And that is because the water is sitting inside of the plumbing for a long period of time. And to just get fresh water into the home, that's why you would flush for that long. And so in our influent condition, we did profile sampling 3 to 4 times in each home. And we collected the profile of the entire 10 gallons. And we wanted to know, were there high levels of lead in the first liter or the second liter or later on? And so the first 15 bottles were 1 liters, and those covered 4 gallons. We flushed the water for 10 gallons and then took a 250 ml sample, flushed again for 2 gallons, took a 250 ml sample, and then flushed again for 2 more gallons, 250 ml sample, and flushed again. And so we actually kept all of the water that was flushed, and that was a total of 6 gallons. We mixed that in order to get the sample 19 so that we could get a full capture of what the water looked like when considering the lead levels. And so recommendation is 30 seconds to 2 minutes. This whole profiling is flushing over 8 minutes so that we can see periodically how much flushing do you need in order to reduce lead levels. And so when looking at our home with sustained lead, these are the 3 profiles that we had. In the beginning on day 0, you had low levels of lead in the first few samples where they were below 10 micrograms per liter. We believe that those were just low because the resident was in the home the day before and they had normal water usage, because all of the water in the 3 profiles was higher than 10 micrograms per liter, no matter how long you flushed it or flushed it up to 8 minutes. The day 20 lead levels were a bit higher than the day 0, and that is because normal water use in a home is about 120 gallons per day. We reduced that to 30 because no one was in the home. And so lead levels increased due to that. And so the POU performance in this home was pretty good. It reduced the lead levels for most of the days of sampling, with 2 spikes in one of the duplicates before reaching 100% capacity. And we captured all of the water that was filtered. And then there was 1 spike in the other duplicate right after reaching 100% capacity that was above the 10 micrograms per liter, but both of the spikes, well, all 3 of the spikes that we saw were below 15 micrograms per liter and reduced influent lead. In our home that had the disturbed lead service line, we had really, really high levels of lead on day 0, which is expected because when you first flush with a pipe that has been disturbed, you have rusted lead particles around them, around the inside of the pipe, along with iron and other metals. And so those would be the first that come out. When you, over time, disturbed lead service lines typically stabilize, and that's something that we saw in day 8, 14, and 20, those profiles. However, no matter how long you flush them, you still did not reduce lead levels to safe levels of lead. For POU performance, these filters struggled to reduce lead levels below 10 micrograms per liter, even before reaching 100% of their capacity. And this is consistent with some of the results that we've seen in my first manuscript that had particulate challenge waters. Additionally, there is more research being done that shows that these filters have more problems when it comes to removing particulate lead. And so in homes in a city that utility knows there are disturbed lead service lines, they may want to see the effectiveness of the filters that have been distributed, because they would struggle to remove the lead that is coming out of these pipes. And so for phase 2, we had our 21 homes in New Orleans and Enterprise, Louisiana. We had 8 homes in New Orleans, which represented a large city, but with very old infrastructure, with a lot of lead service lines and lead service line replacements occurring in the city. Enterprise is a rural, very small community that has very bad cell phone service and internet service, and they have less than 300 people. They have a lot of problems with high lead, iron, and manganese, and we compared the results from both of them. They were sent sampling kits, and their sampling kits included a faucet filter, their 26 bottles for weeks 0 to 12 if their filters made it that long. They were given instructions, reminder cards, Sharpies, and a magnetic stopwatch that they could put on their refrigerator. And this is a closer look at, here's what their reminder card looks like, where they took the unfiltered sample on one day of the week, and then the following day they took the filtered sample, which these are after 6 hours of stagnation, which represent the worst levels of lead in a home. And so when looking at the lead levels in Enterprise, which is the top number, well, the top box, and New Orleans at the bottom box, you see that Enterprise had median lead levels of about 1, but the filters reduced them to below detection. And in New Orleans, they had median lead levels that were still pretty low, but the filtered water was below detection, and it had an average of 96% removal, and all lead levels for all of their homes over all of their weeks was less than 1 microgram per liter. When looking at iron, you see that the median iron level for the enterprise home at the top is around 300, but the filters removed it all into well close to below detection limit. You see the contrast in New Orleans, where they barely had iron in their water, and their median was at the detection limit, but the filter still removed all that was present. And the removal efficiency, which is representative of what happened in Enterprise rather than New Orleans, is about 83%, and all samples were below 171, which is a lot lower than the 300 micrograms per liter of the secondary maximum contaminant level. Now you have manganese. In the enterprise homes, you have really high levels of manganese at 100 micrograms per liter, and the filters did not have to reduce that as much as it did in the lead and iron conditions, but it still had high reductions. And in New Orleans, the same as the iron, it had really, really low levels of manganese, and the filters reduced that to low levels. And so the removal efficiency, because of the enterprise homes, was around 74%, and all manganese levels were below 180 micrograms per liter. And so when looking at flow rate over time, enterprise homes are 13. We saw them start at different flow rates, and these are in liters per minute, and the x-axis is over the weeks. The different variability in starting flow rate is based off of like the water pressure in a home or their starting iron concentrations, but that is the baseline that the resident is looking at when it comes to, this is how my filter is supposed to work, and this is how slow that it can go before I don't want to use it anymore. And so as you can see in enterprise, none of the filters, or most of them, did not reach 50% of their capacity, in comparison to the New Orleans homes, where they had pretty high flow rates, and most of them did reach their 100% capacity of 12 weeks. And even the homes that made it to 9 weeks or 8 weeks, it was because of their filter light changing. And so they did get the most use out of their filters. And to put this into perspective, 1 liter per minute, which is this nice little line where both communities fluctuate at, is about 30 seconds to filter a cup. Where some of the enterprise residents at this very bottom had flow rates of 0.1 liters per minute. And that means that they waited 2.5 minutes to filter a cup before they determined it was clogged. And so, but clogging, defined in NSF ANSI 53, is a reduction of 75% of the initial, where if you look at enterprise, the average reduction in flow rate from initial before clogging is 62%. But looking at the different residents, they chose differently. So at ELA 1, that was a very close, that is our first bar. It's close to that 75% reduction. But if you go all the way to enterprise or ELA 14, the short bar in the enterprise series, they didn't wait that long to say that their filter clogged. And so the decisions on what clogging looks like are very different. And in the homes in New Orleans, they only saw an average of 16% reduction before they determined clogging, or the couple homes that did say that their filters clogged, they were actually a bit higher than the enterprise home that said it clogged around well, Enterprise Home 14, they are higher, but it is based off of their perspective and their use of the filter and how much water they use. And so we decided to try to control some of those variables in a lab study. And we tested 2 duplicate filters that were the same use in the field study of Enterprise and the unoccupied homes. And we wanted to see, as we increased our iron concentration, how much iron is required to reduce the flow rate. But for faucet 1, you had 23 milligrams of iron required to clog that one. And then duplicate 2, 46. And so that shows the variability, even if they were on the same rig, when it came to reducing the flow rate. And so because you have the additional factor of not all filters are made the same, we have our prediction of iron's impact on filter life had a very low R-squared value of 0.56. So we know in general, based off of the other data, that iron does impact the capacity when it comes to the weeks that these filters are able to run. But there are so many other things that we aren't able to definitively say, this is what clogging looks like, and this is how we estimate it. But we are able to say that clogging predicted about or is responsible for 50% of the reasons why the filter's clogged. And so my conclusions, we have from manuscript 1, we validated the performance of the POUs, both positive and negative, in our field and lab studies. We operated these filters to 200% capacity, and we also used them for a lot longer than normal people would. And that did not seem to have adverse effects on lead removal. Additionally, our POU failures, we attribute them to manufacturing flaws and particulate lead. Manuscript 2, we were able to validate the anecdotal reports of premature clogging from residents that is caused by iron concentrations. The POUs effectively remove both iron and lead, and we were able to see that there isn't any adverse effects of the presence of iron on lead removal. And we saw that clogging due to iron can cause the POUs to be more expensive than store brand water, as well as less of a pain if you have to wait several hours in order to filter a gallon. For manuscript 3, for our longitudinal study, we saw that flushing did not reduce lead to safe levels in our unoccupied homes. The POUs for the home with sustained lead had high removal. However, the one with the disturbed lead service line, the POU struggled, like we've seen in research that shows particulate lead can be an issue. The POUs in the 21 homes in Enterprise in New Orleans demonstrated good removal in reducing lead, iron, and manganese, but none of the Enterprise homes reached 50% of their capacity because they clogged. But New Orleans did not have experience with clogging. And that shows a big disparity because small rural communities that have high iron and manganese would essentially have to replace their filter 2 to 4 times to get as much of a filter life as communities like New Orleans with low iron and manganese. So recommendations for future work. The technologies have been improved. So since we started our study in 2018, like I said before, the threshold for certification has been decreased in the winter of 2019 from 10 to 5 micrograms per liter. So the filters you buy in the market, we expect that they would perform better than the ones that we had in our lab. There are regulations, including the lead and copper rule revisions, that are advising municipalities and consumers to distribute these POUs to residents, but not all POUs work well for every community. And so we encourage that the utilities would benefit from testing the effectiveness so that they can determine which POU is best for their community specifically. And so also POU misuse. Consumers are often advised to not use hot water in their filters. However, they do so anyway. When we told our residents and we installed their filters to not use hot water, about 57% of them still used hot water through their filters, but that can be expected because we're asking them to use it for cooking and drinking. And we don't know the ramifications of not using hot water when it comes to lead removal or what it does to a POU. So research needs to be done to understand what is the practical importance of not using hot water so we can communicate that to residents. And more work is needed to determine what specific factors, including particle size and surface charge, that make waters difficult to treat. And so this is work that I have actually begun doing over the past 10 months of looking at the physiochemical properties of soluble and particulate lead that may make the waters difficult to treat. And so that is something that I'll be working with another graduate student to write up in the spring. And so my dedications, I would like to dedicate my doctoral degree to my grandfather, Orville Purchase. When I set out to go to Virginia Tech, I told him that I would get both of these degrees in his name because it was unheard of to actually go to graduate school on a full assistantship from a community or even from our family. And so just want to know I actually got here to the final days. Also, I'd like to dedicate this research to Pauline Brown and Eugene Smith from Denmark, South Carolina. My switch from construction to EWR to work with Mark has been inspired by these citizen scientists because I was not able to help them fix their water, but looking at POUs can help to educate residents on how to protect themselves. And so this research is dedicated to all community citizen sciences that are fighting for their safe drinking water. And so I would like to thank the PIs on the HUD grant, Dr. Mark Edwards, who's my advisor, Dr. Kelsey Piper, Dr. Jeffrey Parks, and Dr. Adrienne Katner. She works at LSU Public Health School in New Orleans. Missed to add that part. Sorry, Adrienne. I'd like to thank you guys for entrusting me to execute this work. And I hope that I was able to bring your dream and vision into reality. And I'd also like to thank you, Dr. Vicasland, for being on my committee, and for all of you for being on my committee and helping guide this work. But the people to thank and who really just got this work across the finish line and even filtered 6 hours for a gallon are these undergraduate students. I had the pleasure of mentoring 12 over the course of the past 3.5 years. And it's been an honor to mentor them and watch them grow up and graduate and do great things, but they definitely made coming to work worth it. And I'd just like to say thank you all to just my family, my friends, my mentors, research group members, counselors, for helping me through this graduate journey. And I will be taking questions now.
So thank you, Jean. At this time, we will open questions up to our in-person public audience and virtual public audience. So if you have a question, please feel free to ask it.
Yes, Yang. Yang asked for advice on choosing POUs as a young dad who is unfamiliar with chemistry and who also lives in an older home. I would say to look at the certifications for these POUs on the back of their boxes. Also, don't buy them from like on Amazon, they do have some fraudulent filters. And reading on the back of those filters, seeing what contaminants are just available and what they're certified for, I would say to look at those when it comes to what may work, as well as a lot of cities are doing free testing of water. So you can probably send in a test of your filtered water to see how well your filter is performing, and if that one works well for you. I am not sure how they decided on the fine particle size for, Catherine asked, how did NSF 53 determine what the particles looked like when for their challenge water, and why they chose fine and bigger particle percentages? And my answer is, I'm not exactly sure. The synthetic waters that they did create, one of the big concerns with researchers now is that they are not representative of what are the particles that are seen in the field or in regular drinking water. And I do know previous work by people in Dr. Edwards' research group showed that the filters had issues with particulate lead. And so they had to begin to include that particulate challenge water, but how they decided to do that or create that, we're not sure. Tulu asked whether or not why dumping the first batch of water is important, and if that happens with all filters. There are residuals that help to store those filters in their packaging, and so that allows for them to be flushed out. If the filter, it needs to be moistened, that will allow for that to be flushed out too. And it is often recommended for both pitcher filters. It wasn't in that manual, but also in faucet filters, they ask you to run it for 5 minutes before you actually use the water. And you can see on a faucet filter that like the water is cloudy up until it runs clear. And so those are different elements, but they're not dangerous in that regard, but it's how they are manufactured. So for the homes that we tested, we just looked at their geographical location, and they had to have had in previous sampling greater than 5 micrograms per liter of lead. They had to not be in apartment buildings and be in single family homes. And to be able to have faucets that had removable aerators so that we could actually install the POU. But in Enterprise, they were not on well water. And in New Orleans, none of those homes were on well water either. But we did try to work with the well water community, but that didn't go as well when in execution. Emma asked, what were we able to give back to the community members who participated in our longitudinal study, and give back as far as information for their participation, or how we were able to work with them educating. We gave them a replacement filter cartridge and their filter unit for free, based off of IRB. And then we did send them a water quality report that did explain their contaminant levels and which ones were elevated and which ones were not. And also gave them our contact information if they had more questions. But as far as more than that, we did not. Emma asked, what is the an example of why the distribution of lead in the homes in Enterprise were different from Louisiana? Is that, well, not Louisiana, New Orleans? The standard deviation was higher. And that is just for water quality over time, especially with lead. Lead has multiple sources. It can come from in-home plumbing through the fixtures, or in the lead service lines down higher up in the water system. So water typically fluctuates in general, and I believe that because of those particulates, they fluctuated even more, where soluble contaminants may not have fluctuated as much as the particles. Dr. Scales? I would say that my most surprising results happened in manuscript 1. It was the fact of cutting open that filter and seeing that slit, and how much manufacturing impacted the performance of these filters. That wasn't a variable when beginning to test that we accounted for, because at first I was a little upset that it messed with my statistics. But that is a very important factor to include. And the second one was just how bad the flow reductions were in the enterprise homes in comparison to the New Orleans, and how patient those residents had to be in order to actually use their filters and get clean water. Freddie? He asked whether or not, based off of my research, would we see similar trends in newer technologies like refrigerators that have filters in them. And I am not sure, because all of these different technologies do behave differently, and how they are able to remove particulates inside of each like actual unit or type of refrigerator is different. And Jessica? Managing expectations. I believe that the expectations that were given was that these filters were going to fix stuff, and they work for everyone. That is not what the manufacturers say, and that is not what we should say. The manufacturers don't say that, so they're not getting sued. And we can say that these filters are really effective at reducing lead levels and showing them that they are, so that when you do have those couple of spikes or those couple like manufacturing failures, it's not a big shock, and you're not distrusting me, is that these filters have shown to be pretty effective, but they all have limitations similar to lead service line replacement, or as we've seen, flushing does work for some homes, but not in the ones that we tested. And so by making sure the public knows in general that this isn't perfect, is how I would communicate that messaging. So anything that you come after that, they will be able to respond less skeptically to your work. And is there any in the chat? Okay. Can I look at them? Also, I know a lot of people weren't able to stay, but there's a link at the top of the chat where you can click on it and submit your email, and I can send you the recording of this presentation. And so there is a question on ionic strength. Okay, how do I get a little bit higher than that? Okay, was there any disinfectant in our, come on, be my friend. Okay, was there any disinfectant used in the synthetic waters? No, there was not any disinfectant used in our synthetic waters. And how much difference were there in ionic strength between feeds with high and low iron? And so for ionic strength for both of the, for all of the iron waters were similar. We didn't add additional hardness, but the pH changed. For the lower iron as well as the soluble iron concentrations, for soluble, we needed it to be below 5. And if you go above 5, it becomes particulate, but our pH was to aim at 6.5 with the same other ingredients for those synthetic recipes. I believe that similar to the future work that I'm doing, understanding what makes lead difficult to remove specifically, or the mechanisms, maybe there being some studies to understand what those small communities' additional problems may be. And then trying to generalize from that, and that will allow for you to narrow down. That will allow you to narrow down from like that 10 POU brands to like maybe 3 technologies, and then testing to see if those do work for you. However, people have preferences. They like faucet filters versus pitcher filters, and all of those things do have impact, but we do need to be more vigilant in looking at what we can do for those rural communities with discolored water, because giving them POUs is not that effective. However, also distributing bottled water is very expensive too. So finding other solutions to assist in their communities. All right. One more from James. I am unsure, James. That sounds like really great future work. That can be someone else's PhD. But thank you all for attending and just being supportive and asking questions.
Well, on that note, it sounds like she's done answering questions. Everything else is going to be future work from here on in. So, but seriously, thank you all for coming. And today we're going to be meeting at India Garden to celebrate Yang's successful PhD dissertation. Are you going to be there?
I hope so.
Okay. So Jeannie will be there, and we will know the outcome of this at that time. And so if you want a free buffet at India Garden, feel free to come. So that said, I think we're done with the public portion of this presentation.